Hi, I'm Nalin Suravira, and this is our lesson number 1 for grade 8 students, English medium students. Subject is Information Communication Technology. We did some lessons prior to this, but those are for grade 9 students, and by this series, we are going to do some sessions for grade 8 students. Under ICT or Information Communication Technology, the lesson number 1 cover number systems. Under number systems, we are going to talk about 4 different number systems. One is normal decimal number system, digital or binary number system, octal number system, and hexadecimal number systems. But we are going to talk about deeply, we are talking about digital number system and the decimal number system. Use of number systems. Now already we know decimal number system, that is starting from 0 and ending up with 9, and using those 10 different numbers we can represent any value. We know basic calculations, addition, subtraction, multiplication, division, and by using these basic mathematical functions, we can do lot of calculations. Then why we are learning different number systems except decimal number systems like binary, octa, hexadecimal, these kind of things. You see, okay, now there is a word hello. There are some numbers, zeros and ones and zeros, and what are these? What is the interrelationship between these? Can anyone say what is the relationship between the hello and these ones and zeros? These ones and zeros are numbers represented in binary or digital format. That we can say hello is some letters, and it has a meaning. Hello in English, it is English word. Now you can see there is a H equal to 0 1 0 0 1 0 0 0. E equal 0 1 1 0 0 1 0 1. What is the meaning? It is mean this each letter is represented binary digit, binary number, not a digit, a binary number. H is represented as 0 1 0 0 1 0 0 0. This is how signals are sent to computer when we are typing. When we type H, keyboard generates a signal as 0 1 0 0 1 0 0 0. I don't know whether you know, some time back, it was I think around the First World War, there was a small machine known as Morse code machine. During that period there was no telephone, only signal sending method was Morse coding. Morse coding was also sent via a machine that has this kind of a 0 and 1 signal. Instead of that, they were using small short mark, and then there is no mark. By using that, they were sending messages throughout the world. Most of the machines were wirely connected, then there were some machines operated without wires also, remote, but most of the machines were wire connected. And similar manner, when we are pressing a digital alphabetic letter in our keyboard, or numeric key on a keyboard, it generates a signal, and it said send the signal to processor. The processor understand only ones and zeros. What is the meaning of that? In a processor, there is a special part known as clock. By this, it is what is clock? Clock we use for know our time. But this is different. It is not only made for know our time. This clock is for generating pulses. When we buy a computer, we check what is the speed of the computer. This speed of the computer is determined by the clock speed of the processor. This clock generates pulses. These pulses are basic intervals between these ones and zeros. These in between intervals, we put ones and zeros and make a signal that is understandable to computer. By a keyboard, by a mic, sound card, by a VGA card, we create a signal and put in those spaces, that in those pulse, in between pulses. And this pulse, this signal goes to processor, and processor process these things in according to given commands by our softwares, and output will come as a image or video, sound, a document in different way that humans can understand. Computer only understand. Computer is a machine. Computer is only machines can only understand whether there is a current flow or not. Based on that, they can create different kind of processors. In computer, there is a small in computer we use very small flow of currents, that is considered as 1, and when there is no flow, it is considered as 0. By using those two signals, we can do different kind of processors, different kind of work, like image processing, typing documents, processing video, or doing complex calculations, watching internet. All these things happening using these small 2-number signal systems. Therefore, in order to know the basics of computer, that is why we are learning this number system, or binary or digital number system. You know, when we type a document, it is also converted into these ones and zeros. When we scan an image or take a photograph, it is also converted into ones and zeros. When we watching a video, it is also converted into these ones and zeros or digital format. And also, when we play a sound, that sound also converted into ones and zeros. Therefore, whatever we do using computers, all the things are converted into digital format, because computer can only understand this digital number system in order to communication with humans. For input data and take outputs, computer only use binary system. That is why we learn this binary number system. What are the types of number systems that we are going to use in ICT? We are going to use 4 different number systems, or we are going to learn 4 different number systems in ICT. The main one is binary format. It has only 2 symbols, 0 and 1. Its base is 2, and we are using octal number system. Octal number system, that is more similar to decimal number system, but it doesn't have that much numbers or symbols. It has only from 0 to 7. This maximum value is 7, minimum value is 0, and its base is 8 because it has 8 symbols. And decimal number system is the common number system that we are using in our day-to-day life. It has 10 symbols and its base is 10. Then the last and least, the hexadecimal number system. Hexadecimal means 16 base number system. It has 10 numerical symbols and also some alphabetical or letters in that number system. The base of number system. Under this base of number system, we are going to explain these 4 number systems, because binary number system, octal number system, and decimal number system, hexadecimal number system. In binary number system, base is 2, octal number system base is 8, decimal number system base is 10, hexadecimal number system base is 16. How we convert number or decimal number into binary number system? Here we have shown example. As example, we are talking about number 101. How we convert into binary? 101 you have to divide by 2. In any number system, when we are converting from decimal to that number system, what you have to do is you have to divide that decimal number from base, what you are asking to convert. That when we are converting decimal to binary, binary base is 2, therefore you have to divide the decimal number from 2. Here you have to divide 101 from 2, and you can see it comes 50 is the answer, and there will be remaining 1, because 50, when you divide 101, you can have answer as 50, but there is 1 is remaining after division. Then you have to divide the 50 from 2. Again, when you are dividing 50 from 2, there will be nothing remain, only 25 will be the answer. Then you again divide 25 by 2, then you can have the answer is 12 and 1 is remaining. You divide 12 by 2, the answer will be 6 and 0 is remaining. You can divide 6 by 2, again answer will be 3 and there will be nothing remaining. Last, you divide 3 by 2, and the answer will be 1 and there will be 1 remaining. Then from from the end to the beginning, you have to write the digital or binary number that is coming as answer. The remaining numbers are the answer, starting from the end and conclude from the to the beginning. Here it will come as 1100101 base 2. Again, there is another example, 187. You are converting decimal number 187. You are converting into binary. Again, you divide 187 by 2. Answer will be 93, and there is remaining 1. 93 also you divide by 2. Answer 46, remaining 1. You divide 46 by 2. Answer 23, and nothing remaining. You divide 23 by 2. Answer is 11, remaining 1. You divide 11 by 2. Answer will be 5 and remaining 1. You divide 5 by 2. Then answer will be 2, remaining 1. You divide 2 by 2 and answer will be 1, nothing remaining. Then you write from end to beginning. That will be the binary number of the decimal value 187. It is 101111011 base 2. Same way, now we are converting decimal number to octal number. Here now you can see the same kind of a pattern. Now here the at octal number base is 8, that you have to divide decimal number from base. Base is 8, therefore 101 we divide by 8. Answer will be 12 and remaining 5. Then again we divide 12 by 8. Answer will be 1, remain 4. Same way, we starting from big end at 1, 4, 5 base 8 will be the answer. Then again there's another example, 287 convert into octal number system. 187 converted into octal number system. Here also we divided by 8. When we divided 187 by 8, answer will be 23, remaining 3. When you divide 23 by 8, answer will be 2, remaining will be 7. The octal number of decimal number 187 will be 273 base 8. Hexadecimal number system. Hexadecimal number system, now again same numbers we convert into hexadecimal. As you see, again we divide by the base. Base is the 16, therefore 101 we divide by 16. Answer will be 6, remaining 5. Therefore, according to the hexadecimal system, 101 in decimal number form, the answer will be 65 in hexadecimal number system. Okay. Now, it's an interesting one. 187 we convert into hexadecimal. When we divide 187 by 16, we can see answer will be B. B mean 11. Answer will be 11 and the remain is 11, therefore we put B. The answer will be BB base 16. Under decimal number systems, we have learned decimal number systems in previous classes under mathematics subject. You know, in decimal number systems and every number systems, we use several principles. One principle is position value. You know that in decimal number system, the least place value is ones place, then the 10th place, and the 100th place, thousands place. Like that, it goes on to the positive side. Here, you can see under this diagram, ones place is marked with one pebble, and 10th place you can see 3 pebbles, and 100th place you can see 2 pebbles. And here is the basic calculation for this. 100 place is 10 into the power 2 multiplied by 2. That means 100 multiplied by 2. The 100th place 2 pebbles represent 200, value of 200. Then we go to the 10th place. It is 10 to the power 1, and it is multiplied by 3. That means 10 to the power 1 means 10 value, place value is 10, and it's multiplied by 3. This 3 pebbles represent 30. And here 1 is multiplied by 10 to the power 0. 10 to the power 0 means 1. 1 multiplied by 1 is 1. Therefore, this 1 pebble here is 1 place represent 1. Therefore, after you add all these 3 together, it is 231. It's same in binary number system. Only thing is, the difference is the place values are far more smaller in binary number systems. The first place value is 1, that is 2 to the power 0. 2 to the power 1, it is second. The 2, the place value is 2. 2 to the power 2, the place value is 4. And it also increased 2 to the power 3 is the place value is 8. Like that it goes on. But here what we can see, 101 base value is 2. You can see 2 to the power 2 is multiplied by 1. That means 4 multiplied by 1, the place value is 4. And here 0 is multiplied by 2 to the value 2 to the power 1. 2 to the power 1 is 2 multiplied by 0. Any number multiplied by 0 is 0. Here the last 1 multiplied by 2 to the power 0. That means 2 to the power 0 means 1. 1 multiplied by 1 is 1. That when you add all these answers together, it comes 5. 101 in binary is 5 in decimal. Why we are making this kind of jargons or like complex systems in our life? Because now we can understand decimal number system, we get used to it, we know how to add, subtract, multiply, divide, we know all the mathematical calculations. Why we are making this into difficult by converting into decimal and make things complex? Because computer can't understand this decimal number system. Computers and machines only understand whether there is electricity flow or not. Electricity flow is identified, one is identified as a electricity flow. 0 is identified when there is no electricity, it is identified as a 0. Those are the two values. Those two values represent all these calculations. When we are calculating any complex mathematical equation, it is converted into ones and zeros. That's how computer can understand. When you are pressing number 9 in computer, it convert into digital form or binary form, it will goes to computer as 0001 001. That means computer has a pulse generator. That means there is a clock. Each time there is a time sequence goes. During these time sequences, if there is no electricity goes in the circuit, it identified as a 0. During each pulse, if there is a current flow, that is identified as a 1. Therefore, when you press number 9 on keyboard, it will create a signal as 0001 001, and it goes to computer, and computer identified as a digitally 00001 001. It understand like that, not as 9, and it do all the complex calculations, and again it sends to the monitor signal the same digital format. Monitor understand it. Monitor show it as number 9 to us, but actually the signal doesn't come as a number 9. It come in binary format. That is why we need to learn binary number system except decimal number system. Okay, here there are several examples that we will explain how to convert decimal numbers to binary numbers. Okay, example 13 in decimal format, we convert into binary format. 13 you divide 2, 13 divided by 2, and answer will be 6 and remaining 1. Again 6 divided by 2, answer will be 3 remaining 0. When we divide 3 by 2, answer will be 1 remaining 1. Again we do divide 1 by 2, answer will be 0 and remaining 1. We will start from the end of the calculation, and we will write it as 1101 in base 2. That is the answer. 13 in base decimal number system is 1101 in digital number system or binary number system. Therefore, there is a small table. It explains what are the numbers that we are dividing. 13 divided by 2, output will be, the answer will be 6, and the remaining will be 1. 6 also divided by 2, output will be 3, remaining will be 0. 3 divided by 2, output will be 1 and remain will be 1. 1 divided by 2, there will be no answer. That means there is no 2 there, and remaining will be 1. Then we will go to the next example, that is 34 in decimal format. We will convert into digital format or binary format. 34 divided by 2, answer will be 17 and there will be nothing remaining. 17 divided by 2, answer will be 8, remaining 1. 8 we divided by 2, answer will be 4, there will be nothing remaining. 4 divided by 2, answer will be 2, there is nothing remaining. We divide 2 by 2, answer will be 1, nothing remaining. We divide 1 by 2, answer will be 0, there will be only 1. Then again we write from the end to the beginning. Its answer will be 100,010 into the 2. The base will be 2. Therefore, 34 in decimal number format, after converting into digital or binary number system, is 100010 in binary format. Again, there is a table for explaining the whole thing. Now we divide again. There's another example. These are all you can see in your textbook. 49 in decimal format we convert into digital format. 49 divided by 2, answer will be 24, remaining 1. 24 divided by 2, answer will be 12, remaining 0. 12 divided by 2, answer will be 6, remain 0. 6 divided by 2, answer will be 3, remaining 0. After we divide 3 by 2, answer will be 1, remaining 1. After we divide 1 by 2, there will be nothing, and remaining 1. There will be from the end to the beginning. Answer is 49 in decimal format is equal to 11001 in digital format. Converting binary numbers to decimal numbers. When we convert binary number into decimal format, we have to do simple kind of a calculation. First we have to write the binary number with some space, and then we have to write the place value of that each digit. Then you have to multiply binary digit with place value, and you have to obtain the place value in decimal format. Then you have to add these decimal values together. Then ultimately you will have answer that binary number. What is the value of binary number in decimal format? Here you can see there is a binary number 101010000. Then you write the place values of each of these. We will starting from right side, 2 to the power 0 place, that is the 1 place. Second place is 2 to the power 1, that is 2 value, place value is 2. 2 to the power 2 place value is 4. 2 to the power 3, place value is 8. 2 to the power 5, its place value is 16. 2 to the power 4, place value is 16. 2 to the power 5, place value is 32. 2 to the power 6, place value is 64. 2 to the power 7, place value is 128. And here, based on the number binary digit, we have decimal values only in 128 place value and 32 place value and 8 place value. Therefore, you add 128 and 32 and 8. The answer is 168 in decimal format. In same manner, you can convert any digital value into any digital value or binary value into decimal format. Here there is another example. Under this example, we are converting 10111 in decimal format into binary digital decimal format. Here we have 1 multiplied by 2 to the power 4 plus 0 multiplied by 2 to the power 3, 1 multiplied by 2 to the power 2, 1 multiplied by 2 to the power 1, 1 multiplied by 2 to the power 0. Therefore, here the place values is 1 multiplied by 16, 0 multiplied by 8, 1 multiplied by 4, 1 multiplied by 2, 1 multiplied by 1. Therefore, now we can have the decimal place value 16, 4, 2 and 1. Then you have to add all these together. The answer will be 23. Therefore, 10111 in digital or decimal digital or binary form can convert as 23 in decimal format. and here this value is 10010. Again we can convert into decimal format. 1 is multiplied by the first value 1 is multiplied by 2 to the power 4 plus 0 multiplied by 2 to the power 3 plus 0 multiplied by 2 to the power 2 plus 1 multiplied by 2 to the power 1 plus 0 multiplied by 2 to the power 0. Here decimal values multiplied by the place digit. 1 multiplied by 16 plus 0 multiplied by 8 plus 0 multiplied by 4, 1 multiplied by 2 plus 0 multiplied by 1. Here decimal place values will come as 16 and 2. When you add those two together, 18 will be equal, the 18 in decimal format is equal to 10010 in binary format. This is the answer. Here another number, here this number is 11111, convert into in binary format, convert into decimal format. Here we put place value 1 multiplied by 2 to the power 4 plus 1 multiplied by 2 to the power 3 plus 1 multiplied by 2 to the power 2 plus 1 multiplied by 2 to the power 1 plus 1 multiplied by 2 to the power 0. Therefore all the place values are positive because all are marked with 111s. Therefore 1 is multiplied by 16, that is the place value in digital format. Add 1 multiplied by 8 plus 1 multiplied by 4 plus 1 multiplied by 2 plus 1 multiplied by 1. Therefore all the place values are positive. Therefore digital in decimal format place values are 16 plus 8 plus 4 plus 2 plus 1. Therefore all you can add together, that will be 31 or 1 in digital format is equal 31 in decimal format. Binary representation of data and instructions on computer. I told you computer can understand only 1 and zeros. That means there is current flow or no. That is only thing that it can understand. When you speak or when you try to recording, like what I do now, I use a small microphone. This microphone microphone generate electricity flow, that is we considered as an analog signal. That means based on my volume, sound, intensity, it generates electricity flow. When my voice goes up, it goes up like that. Therefore it is analog data. Analog means continuous data, and it goes to sound card. This sound card converts this analog wave electricity flow into digital format, and it goes and record in computer hard disk. The sound card's purpose is to converting this analog data, because computer can't understand analog data directly. Therefore there are peripheral devices in order to convert this analog details, analog informations into digital format. That is why even we can't do it by humans. Therefore we have created different devices, and we have assembled these devices into computer to do that. Therefore whatever I say, it will convert into electricity flow that is going up and down based on my voice and other features of the sound, and this is again converted through sound card, and it goes to computer and record. And when we want to play it back, this digital signal generated from that was stored in computer goes back to the sound card, and sound card will generate a wave signal, analog signal to the speaker, and the speaker will replay what we said. That is how it works. Converting binary numbers to decimal numbers. When we convert binary number into decimal format, we have to do simple kind of a calculation. First, we have to write the binary number with some space, and then we have to write the place value of that each digit. Then you have to multiply binary digit with place value, and you have to obtain the place value in decimal format. Then you have to add these decimal values together. Then ultimately you will have answer that binary number, what is the value of binary number in decimal format. Here you can see there is a binary number 101010000. Then you write the place values of each of these. We will starting from right side, 2 to the power 0 place, that is the 1 place. Second place is 2 to the power 1, that is 2 value, place value is 2. And also when you are pressing A in alphabetic key, it will generate a signal 1 0 0 0 0 0 1, and it will go directly from keyboard to the computer, and computer will understand this 1 0 0 0 0 0 1 as number letter A, and it will store in computer. And when you press number 9 in computer in digital numeric keypad, it also generate 0001 001 as signal, and it will go directly to the computer, and computer will understand the user is sending a message that 0001 001 as number 9, and it will display it. In computer, we have to understand the process. We are input data. We input data, and feed data, text, image, and sounds into computer, and there is a processing goes on. Processing goes on based on our instructions. Computer process this data into information and convert this binary data will convert to information and comes out in human understandable way after we process this data and create a report. Conversion from binary back to text, images, and sounds, it is happening like that. Here it explains that we are using only few peripheral devices, webcam images, keyboard text, and those are coming in digital format, and it goes into computer. After go it to computer, processing this entered signal, and those are processed by a microprocessor, and it will remain in computer in temporary memory, and after processing it goes on to the hard disk or pen drive. As when you need to review it back, you can get it back from there. And after processing also it will give image how this information is displayed on the computer. This signal also a digital signal. Therefore, whatever happening inside the computer, all the things are based on digital format or binary format. These are the things that we should know when we are using a computer we are not going to do the programming also using these ones and zeros. That is used to happen in some years back, but now you can have most of the software developing people know that there are IDEs, integrated development environments, for different subjects. Therefore, you don't need to work hard as some time back. Computer will automatically do most of the work, but in order to get those services done, you need to know the basics. That is why you are learning. Therefore, now